Hello there. So last week we started our intro into acids and bases, and we're going to go over some properties of both acids and bases. There are 5 major properties of acids. The first property we're going to take a look at is that acids tend to have a sour taste. Now, we're never going to use this property to test if a solution is an acid or not in this classroom, simply because some acids can be very strong and dangerous if you ingest them. So we're never going to ingest chemicals in the classroom. However, if you do find some food that has a sour taste, it's because they have an acid in them. So for example, lemons have some acid in them. Okay, because they tend to have a sour taste. Acids also react with metals to form hydrogen gas. This is what happens when you see corrosion. Corrosion of any metal. I definitely spelled that wrong, but whatever. Corrosion of any metal is just an acid reacting with the metal to form hydrogen gas, H2, and this causes the metal to break down. Okay, so corrosion occurs because of how acids react with metals. Okay, acids also conduct electricity very well. They have what's called ions that float around freely inside an acid, and we'll get more into what those ions are later. But they freely conduct electricity. They're very good at it too. They also react with different chemicals called indicators to change colors of these indicators. This allows us to test for an acid or a base. Okay, and finally, whenever we take in a base and we react it with an acid, okay, remember these are all properties of acids here, it's going to form water and a salt. Okay, remember, acid-base reaction, water, salt. Bases also have 5 general properties about them. Property number 1 is similar to acids, a little bit different though, is that they have a bitter taste. Bases tend to have a bitter taste. Okay, if you ever were bad as a kid and had to have your mouth washed out with soap, it's bitter. That's why we don't like it. Okay, bases tend to have a bitter taste. Also, bases in a dilute form tend to be slippery. Okay, this is why soap, for example, soap is a base. When you put water on soap, it becomes a dilute solution, and it's very slippery. It's hard to hang on to. Bases tend to get a little slippery as they form a dilute solution. 3 and 4 are almost exactly the same. Bases conduct electricity. It's based on the same principle that acids are. They form an ion when mixed with water. Okay? They conduct electricity. They also change the color of an indicator. Okay? They'll actually change it a different color than what an acid will change it to. The 5th and final property of bases, it looks exactly the same as the acids. When a base reacts with an acid, it forms water and salt. So all of our acid-base reactions are always going to form water and salt. Now before we can do anything really special with acids, we need to be able to name acids so we can talk about them in an intelligent manner. There are 2 types of acids that we're going to be naming for the most part. The first one is binary. A binary acid is an acid that contains simply a hydrogen plus a single other element. In other words, it only has 2 elements in it. An example of a binary acid would be like hydrochloric acid, HCl. Hydrochloric acid because there's just one hydrogen and then there is a chlorine, so 2 elements altogether. Another example of a binary acid would be hydrofluoric acid, HF. Oxyacids follow a little different pattern for naming. Oxyacids are always going to have a hydrogen mixed with a compound, and a lot of times these compounds are going to contain an oxygen. They're going to have an oxygen in them. So an example might be carbonic acid, or we might have nitric acid. Okay, we'll talk about how those are named here in a moment. Naming the binary elements follows some very simple rules. Let's take a look back at our HCl. So we have HCl. This is hydrochloric acid. There are 4 major parts of naming this acid. Part number 1 is the hydro. Whenever we have a binary acid, we're always going to put hydro in front. So that's step number 1. Step number 2, we need to drop in our element. In this case, our element is chlorine. So step number 2, drop in the Cl. We're going to drop in the chlorine. Step number 3, we're going to add an ic at the end. So step number 3 is we add the suffix ic. And finally, step number 4, we add acid at the end. So that's all there is to it. We have 4 steps. Step number 1, hydro in front. 2, drop in the element. 3, tack on an ick at the end. And finally, add acid. Oxyacids follow a different pattern. We're going to need to worry about different ions of elements. An example of an oxyacid is H2SO4. H2SO4 stands for sulfuric acid. Sulfuric acid, just like that. Okay, there are some significant differences between an oxyacid and a binary acid. Big difference number 1, there's no hydro. There's no hydro in front. It's just the acid name. So here are our steps. Whenever we have an oxyacid, no hydro. Step number 1. Step number 2, we're going to drop in our compound name. In this case, we have what's called sulfuric acid, SO4. This is sulfate, S-U-L-F. Sulfate, like that. That's sulfate. Okay, this is very important. We notice there's an 8 at the end. We're going to have 2 different types of endings based on if it's either ends in an 8 or ends in an ite. Okay, and we'll give you an example of an ite here in a moment. If it ends in sulfate, we're going to add an ick at the end. Okay, if it ends in an ite, I-T-E, you're going to add an O-U-S or us at the end. Okay, and I'll show you another example of that here. So if we take a look, sulfuric acid, number 1, we drop in sulfur or sulfate. We drop in our sulfate. We cross off the 8 at the end. We get rid of that. And we drop in an ick. And we tack acid on at the end. That's how we name oxyacids. Alright, let's do a couple examples of naming acids here. So our first acid here, HBr. So we've got a hydrogen and a bromine. Okay, there's only 2 elements here, so it's got to be a binary acid. It's binary. So here's how the naming will work. Step number 1 for binary, we need to put a hydro in front. Put our hydro in front. Next, we need to drop in our element, which is bromine. So I'm going to stop right there, bromine. Now I need to add an ick at the end, so bromic, because I don't want to put the rest of it. So hydrobromic acid. Okay, notice I didn't fill out all of bromine, I just put enough so I can do bromic. Okay. Next, is this binary or oxyacid? That's the question. If we take a careful look, there are 3 different elements there. We have hydrogen, nitrogen, and oxygen. So it's obviously an oxyacid, especially since it has oxygen there. So we need to figure out what is this guy right here. Well, that guy right there is nitrate. Nitrate. Okay, it's got an 8 at the end. Okay, so we need to add an ick at the end. So to name this acid, we're going to do nitrate, but 8's are replaced with X, so we have nitric, and we have acid. That's all there is to it. This one down here is a bit different. We have, again, another oxyacid, but we have NO2 this time. We can always tell an 8 from an ick because an ite, excuse me, is just going to have 1 less oxygen than an 8. So this right here is nitrate. Okay, that box right there is nitrate, or not nitrate. I apologize. That's nitric acid or nitrite acid. Okay, nitrite. Okay, not nitrate, nitrite, because it has 1 less oxygen. So because it's got an ite at the end, we're going to get rid of the ite and add an us. So our acid is going to look like this. It's going to be nitrous acid. Okay, and that's how to name the different types of acids. Naming of bases is much easier than naming of acids. There's only 2 simple things we need to follow for naming of bases. Number 1, we need to memorize a couple different bases. Okay, we need to memorize the following. We need to know NH3, and more importantly, we need to know OH negative. Okay, those are our 2 big bases. Okay, NH3, this is ammonia. This is the household cleaner you find in your house for cleaning things, ammonia. And OH negative is hydroxide. Okay. All bases are going to produce hydroxides. We're going to talk about that later in the chapter and why they produce hydroxides. Okay. But you need to memorize both of these. Okay. Number 2 is naming of bases follow the ionic rules. They follow ionic rules. So it's going to look like something like this. So we might have something like this. Sodium, that's a positive cation, and our anion is always going to be hydroxide. Okay, so sodium is our cation, C-A-T-I-O-N, and hydroxide is our anion. Okay, and we follow the ionic naming rules. So NaOH is just going to simply be sodium hydroxide. Here are a couple examples of some different bases, and we just simply follow the ionic rules for naming these bases. Notice they all have hydroxide attached to them. Okay, so they're obviously bases. If you see OH, think base. Okay, now for this first one, our first element here is calcium. Ca is calcium, so we're going to have calcium. We don't do anything with that. Don't do anything with the calcium, just leave it alone. And then we attack on the hydroxide. Okay. And there we are. That's all there is to it. We don't have to worry about any prefixes. We don't have to do anything like that. Just calcium hydroxide. K here is potassium, so this is going to be potassium hydroxide. And finally, we have magnesium hydroxide, right? Because Mg is magnesium, so we're going to have magnesium. The last thing I want to talk about here is the uses of different acids and bases. So here are three major acids that we'll talk about: sulfuric here, nitric, and hydrochloric. Sulfuric has multiple uses in the industrial applications. Sulfuric acid is actually one of the most industrially produced acids. Okay, it's used in a variety of different areas, including petroleum, gasoline, and car batteries. Nitric acid is probably one of the most dangerous acids you can come across. Nitric acid can easily burn your skin, and it's also used in explosives. Hydrochloric acid is a much more mild acid. Hydrochloric is actually used a lot in our chemistry lab. We've got some in the acid hood right now as we speak, and it's also used in swimming pools to balance pH. You will find bases much more in your house than you will acids. Some common bases you might run into are ammonia, bleach, and dish soap. All these different bases, are usually very dilute. Okay, ammonia in high concentrations can be very damaging. It actually has a very strong aroma. That can be harmful to your nostrils and breathing passages. Same thing with bleach. That's why it always comes in dilute forms. So if you look carefully on your packaging, you can actually see the concentration, usually in the form of a percent, of how much each of these bases are in your chemicals. Okay, that's all I have for you today. We'll see you in class, and I hope you have a great day.